Okay, welcome to Chapter 6, Lesson 1, Translations. Our learning target or objective for this lesson is to graph translations on the coordinate plane. We've seen coordinate planes in previous chapters. Let's get right to our vocabulary. Our first vocab word, transformation. An operation that maps an original geometric figure, we'll call it the pre-image, onto a new figure called the image. As you notice, the pre-image and image are in red, so those are also vocabulary words just to make you aware of for future reference. Next word, translation. Translation slides a figure from one position to another without turning it. You might want to reference that we're going to probably call translation also slide. A slide is a translation. Once again, you can always pause the video to write down the definitions. And our final vocab for this lesson is congruent. Figures have the same shape and same size. We've seen that also in previous lessons, the word congruent. Okay, we're going to get right into our key concept. Our key concept for this lesson is translations in the coordinate plane. Okay, when a figure is translated, the x-coordinate of the pre-image changes by the value of the horizontal translation A. Horizontal is left to right, so that's the x-axis. So whatever the slide is left to right, that is A. The y-coordinate of the pre-image changes by the vertical translation or the y-axis, translation B. So whatever goes up or down is going to change by whatever says up or down. Going up is always going to be positive, down is negative. As well on the x-axis, going to the right will be positive, going to the left will be negative. Think of the number line. Okay, let's jump into a couple examples here. First example, they want us to graph a triangle JKL with those vertices. And then we're going to make it a translation. So let's graph the triangle JKL. Negative 3, 4. Start at the origin right in the middle. Negative means we're going to the left first. 1, 2, 3, up 4. 1, 4. There is J. K is 1, 3. We go 1 to the right, up 3. There is our K. And L wants us to go negative 4, 1. 4, 1. There is our L. Connect the dots. Make our pre-image. Okay, now the translation or slide is telling us we need to go 2 units to the right and 5 units down. Write the coordinates of its vertices. Remember to do that as well. So we're going to translate 2 units to the right and 5 units down. Let's start with K. 2 to the right, 5 down. 5. That is K. It's our new K prime. And our coordinates are 1, 2, 3. 3, negative 2. Might as well just do the coordinates right when you do the point. That way you're all set. Let's look at J. J, we're going to go over 2 and down 5. 1, 2, 3, 4, 5. There's our new J. J coordinate. Negative 1, negative 1. And our last one, L. L, we're going to go over our 2. Down 5. 1, 2, 3, 4, 5. There's our L. Our new coordinates for L are negative 2 and 1, 4, negative 4. That's L prime, that's J prime. This is our new image. And there we have it. There is our translation of triangle JKL. Now, as we said in the key concept, you're adding the horizontal change and then you're going to add the vertical change to the Y. So instead of doing it on a coordinate plane, on this example, we're going to do it in a table. Okay, here's how we do this. Again, we said our horizontal is added to the X. We're going to the left. The left means we're going to negative 2. And then our Y is being added. We're going up, so that's a positive. So we're going to add 1 to Y. Okay, and then we just, on the vertices of the triangle, we're going to put our X here. Negative 1, negative 2. We have Y, which is 6, negative 3. And Z, which is 2, negative 5. Okay, now, just like our tables from our function chapter. We're just going to plug our numbers in and see what comes out in the output. Okay, our x is -1 plus a -2, and our y is -2 plus 1. Okay, now we're just going to add those -1 plus -2 gives us a -3. -2 plus 1 gives us a -1 still, and that's our x. That's our new image x coordinate. Okay, moving on to the y vertice. We have our x, which is 6 plus -2. Our y is -3 plus 1. Now we just simply add 6 plus -2 is 4. -3 plus 1 is -2. That is y prime. And our last one, we're plugging in 2 plus a -2. And we have -5 plus 1. So -2 plus 2 is 0. -5 plus 1 gives us -4. That is our z prime. That's all we have to do for the chart. We're just plugging in into a function like we had before. Once again, you can always replay parts that you do not understand or write down your questions so we can go over them in class on the next day. Okay, now we're going to sort of take what we did with the first example and the second example, and we're going to combine them into this one. We already had the slide happening. Now they want to see, we're going to try to find out what the transformation was. We want to see what up or down, left and right, how far we went. So we have our pre-image to the left. We have our new image, or our slide. Our slide was to the right. And we're just going to pick out 1 point for each one to figure out. You only need 1 point to find out what the transformation, what the translation was, or the slide. So we're going to call the first one point A. This will be point B. Now here's what we need to do. Just like function tables, remember we were given the input and the output and we had to find the function. It's pretty similar to what we have to do here. So our input, or our pre-image, points are 4, 5, 6, 7. That's -7, 2. That's our vertice for point A. Point B's vertice is 2, -2. That's our output. So once again, we take our -7, 2. We're going to put it into our function, which we know because we had -7 plus, it's called x. Then we have 2 plus, we'll call it y. And that got us to -2. That was our output. Let's think of it as the table. Okay, now we're just going to solve for our variables. Let's look at the first one, 7, -7 plus x, and then our output would have been 2. So we're just going to solve. Now we just have algebraic equation. So we're just going to solve for x. So we have to get x by itself. So we have to move the 7 and add 7 to both sides. X is going to equal 9. And over here we have 2 plus y equals our -2. Solve for y. We're going to subtract 2 from both sides. We got y equals -4. Those aren't our answers though, because remember we're looking for our translation. What was our slide? So what we did was translation. Equals, what do we do for our x? It's a +9, so we move 9 units. You always see the word units moved in translations, 9 units to the right, because it's positive, so it went to the right. And we have -4 units, and it's a negative, so that means it's going down, down. So there we go. There's our function part. We move 9 units to the right and -4 units down. That's how you find the slide when given the 2 points. Okay, our last one. Graph the image after translation and write the coordinates of the new vertices. 3 units to the right and 4 units down. This is going to be something new that we haven't done before on our lessons. This is one you're going to do on your own. So this is an on your own. Will be checked in the morning. So just I'll give you one hint. If anything, make sure you write down the coordinates of the vertices after translating, after you slide it. After you slide it. Make sure you move each vertice, each one, so you should have the same image, but moved as the translation. All right, and one other thing that you need to do for class is you have a graphic organizer to fill out as well. Now it says definition. I just want you to write down the definition because we're going to do the word translation. That's our. I just want you to write down the definition that was given to you at the beginning, but I want you to define it in your own words. In your own words. Okay, and then the second one, you're not going to do an illustration because that's what you're going to do at the bottom 2 boxes. So I want you to list 3 characteristics about translation. What can you think of 3 characteristics about a translation? Then I want you to draw one example, and then I want you to draw one non-example of a translation. And once again, we'll go over those in the morning about this. Okay, and this concludes lesson 1.